Okay, welcome back. So this is the integral we had set up in the last video to try to find the area between these two polar curves. Remember, these 2's in front are because we were calculating just the top part and doubling it to get the total area, and we're subtracting because we found that the area we wanted was a difference of two regions. There will be some problems where you're adding areas. You just have to look at the picture to figure out what you need. Okay. All right, so if I start working on this, this is going to be 2 integral from pi over 3 to pi of r squared over 2 evaluated between 1 plus cosine of theta and 0, and then I still have to integrate that with respect to theta, minus 2 times the integral from pi over 3 to pi over 2, r squared over 2 evaluated between 3 cosine theta and 0, and we still have to integrate that with respect to theta. Now I'm going to go ahead and cancel these 2's. That's kind of nice. Okay. So this piece becomes the integral from pi over 3 to pi of 1 plus cosine of theta squared minus just 0 d theta, minus this becomes the integral from pi over 3 to pi over 2 of 9 cosine squared theta minus 0, and we've got to integrate that with respect to theta. Now here, don't think that exponents distribute over addition. They do not. We've got to FOIL that out. This is going to become the integral from pi over 3 to pi of 1 plus 2 cosine theta plus cosine squared theta d theta minus the integral from pi over 3 to pi over 2 of 9 cosine squared theta d theta. Okay, so let's see what this gives us. I'm going to split this up into 2 integrals. So I think I'm going to move up here. I'm going to say that's going to be the integral from pi over 3 to pi of 1 plus 2 cosine of theta d theta. That part I can do by inspection, plus the integral from pi over 3 to pi of cosine squared theta d theta. Then I'm subtracting the integral from pi over 3 to pi over 2 of cosine squared theta d theta. Okay. So I've got this piece which I can do by inspection. Now both of these pieces involve the same integrand of cosine squared. So here I'm going from pi over 3 all the way to pi, but I'm subtracting what I get going from pi over 3 to pi over 2. That's exciting. So here's pi over 3, pi over 2, and pi. The first integral has me going along this entire interval. I'm subtracting what I get over this interval. What's left is just what I get over that interval. So I can consolidate. I can combine these two now into one integral. So we'll have the integral from pi over 3 to pi of 1 plus 2 cosine theta d theta plus the integral just from pi over 2 to pi of cosine squared theta d theta. Whoops. I can't do that. I dropped a 9. Oh, alas and alack. This is 9 copies of that, so that's not gonna work. Ugh, bother. I'm sorry, I apologize on that, but I'm actually gonna keep this video, partly because this is my second time shooting it, and partly because that's actually a good thing to learn from, okay? Didn't mean to make that mistake, but we'll turn it into a learning opportunity. I inadvertently dropped that 9. Now, these integrands aren't the same. They're very similar, so evaluating them are going to be very similar, but they're not identically the same because of that 9 there. So I do actually need to keep this as these 3 different integrals. Okay. Now, I'm just going to call this A, B, and C. I think what I'm going to do is in the space I've got left, I'm going to work out what A is, and then I'll erase the board and we'll have A, and then we'll work out B and C, reviewing how to integrate cosine squared. Okay, so A is just going to be, let's see, theta plus 2 sine theta evaluated between pi and pi over 3. Antiderivative of 1 is theta, antiderivative of 2 cosine theta is 2 sine theta. So that's just going to be pi plus 0, because sine of pi is 0, minus pi over 3 plus 2 copies of sine of pi over 3 is root 3 over 2. So, let's see, those 2's will cancel. Pi minus pi over 3, that's going to give me 2 pi over 3, and then minus root 3. So that's what I get from part A, and then we've still got to do B and C. So let's give ourselves some space. So we're going to have 2 pi over 3 minus root 3. That was our A, plus the integral from pi over 3 to pi of cosine squared theta d theta. That's our B. And then minus 9 copies of the integral from pi over 3 to pi over 2 of cosine squared theta d theta. Okay. So that's the problem that we need to finish. So, excellent opportunity to review how to integrate an even power of cosine. Okay. So, and the same trick works whether it's an even power of sine or cosine. You start with the double angle formula for cosine. Cosine of 2 theta is cosine squared theta minus sine squared theta. I happen to know that. I usually choose that as my starting point when I'm deriving this. If you want, you can take it a step back and say that 2 theta is just theta plus theta, and this is what you get if you plug into the sum formula. So all of you are going to sort of have to figure out what do you want as your starting point for what you have memorized and then what you derive from there. Some of you may remember what we do. You may have actually already memorized the formula for what cosine squared is. I do have it accidentally memorized just because I've done integrals like this so often, but the way I accidentally memorized it was deriving it. Notice right now, that's the thing I want to integrate, and that's easy to integrate. So I like having those in an equation so that I can get a connection between them. Not so crazy about this piece, but I can rewrite that piece because sine squared is just 1 minus cosine squared. And then I can say that's cosine squared theta minus 1 plus cosine squared theta. So that's 2 cosine squared theta minus 1. If I were integrating sine squared, I would just replace cosine squared with 1 minus sine squared. Now what I'm going to do, this is still equal to cosine of 2 theta, so I'm going to solve for cosine squared. I'm going to add over the 1 and divide by 2. So cosine squared theta is cosine 2 theta plus 1 over 2. So that's what we're going to integrate here. So we still have 2 pi over 3 minus root 3 plus the integral from pi over 3 to pi of cosine of 2 theta plus 1 over 2. I'm going to just go ahead and factor that 1/2 outside of the integral. Same thing here. So that's going to make it minus 9/2 the integral from pi over 3 to pi over 2 cosine of 2 theta plus 1 d theta. Excellent. Now for both of these, I'm going to do exactly the same u sub. I'm going to let u be 2 theta. That way du is just 2 d theta. So we have 2 pi over 3 minus root 3 plus. Now, in order to make that u sub work, I need to have a 2 on the inside. I don't, but I can introduce one as long as I counterbalance with a 1/2 on the outside. But a lot of integrating even powers of sine and cosine is just the bookkeeping, keeping track of all the different factors of 2 that we get. So now this becomes 1/4. The integral from the u value at pi over 3 is 2 pi over 3 to the u value at pi is 2 pi. Cosine of u plus 1 du. Minus 9/4, the integral from the u value, again, is 2 pi over 3. This time the u value at pi over 2 is just pi, and then it's cosine u plus 1 du. So we have 2 pi over 3 minus root 3 plus 1/4 of an antiderivative of cosine is just going to be sine u and then plus u, evaluated between 2 pi and 2 pi over 3, minus 9/4 of an antiderivative of cosine, same antiderivative actually, just sine u plus u, evaluated between pi and 2 pi over 3. So now all that's left for us to do is evaluate this and really hope that we get a positive number, because we were finding an area, and oh my goodness, area needs to be positive. So we will have to cry if we do all this work and we've got a negative number. I don't think we will. I think we're in good shape. Okay. So I'm going to just keep this on the bottom and then simplify it as I move up to the top. So we still have our 2 pi over 3 minus root 3. We're going to get plus 1/4 of what we get at 2 pi minus what we get at 2 pi over 3. So at 2 pi, sine of 2 pi is 0, plus 2 pi just gives me 2 pi. At 2 pi over 3, sine of 2 pi over 3 is root 3 over 2. That angle is in quadrant 2, so sine is positive, and its reference angle would be pi over 3. So its sine is root 3 over 2. Okay. Let's see, so that's our sine plus 2 pi over 3. Okay. And then minus 9/4 of what I get at pi minus what I get at 2 pi over 3. Okay. So at pi, sine of pi is -1 plus pi. And then at 2 pi over 3, we said sine of 2 pi over 3 was root 3 over 2 plus a 2 pi over 3. So at this point, we've just got a bunch of simplification to do. So 2 pi over 3 minus root 3. I'm going to distribute the 1/4, and when I get here, I'm going to distribute the negative. So 1/4 to 2 pi is going to become plus a pi over 2. And now I'm distributing a negative 1/4. So minus root 3 over 8 minus pi over 6, because I can cancel the 2 with the 4 right there. So I basically get 2 pi over 12, which is pi over 6, minus pi over 6. Okay, so now I'm going to distribute this negative 9/4. So negative 9/4 times a negative 1 is plus 9/4. Negative 9/4 times pi is minus 9 pi over 4. Now I'm going to have a negative and another negative that I'm distributing, so I'm just distributing 9/4. So it's going to be plus 9 root 3 over 8 plus the 9 and the, oh, let's see, I got to do this one out. 9/4 times 2 pi over 3. I could cancel. I can cancel. I'm going to get 3 pi over 2. Okay, so let's see. This term, this term, this term, this term, and this term all involve some pi's. So let's just get a common denominator and see what those pieces evaluate to. Looks like I want a common denominator of 12. So this will be 8 pi over 12 plus 6 pi over 12 minus 2 pi over 12 minus 27 pi over 12 plus 18 pi over 12. That's all of the pi pieces. That's going to be some pi over 12s. How many of them? Oh my goodness. 8 plus 6 is 14, minus 2 is 12. Plus 18 would be 30. Minus 27 is going to be 3 pi over 12, which of course in a moment we can reduce to pi over 4. Okay. Let's see, we've got some other pieces. The pieces I'm circling all involve some root 3's. Okay. So I've got, looks like I'm going to want to have a common denominator of 8. So we're going to have minus 8 root 3 over 8 from this piece right here, minus root 3 over 8 plus 9 root 3 over 8. Oh, how convenient. That's minus 9 root 3 over 8 plus 9 root 3 over 8. That's going to be 0. And then I had this one more term of 9/4. All the other terms involved pi's or root 3's. So we're getting this plus 0 plus 9/4, which is 3 pi over 12 plus 9/4, which is pi over 4 plus 9/4, or if you prefer pi plus 9, all over 4. And that's a positive number. Now that doesn't guarantee we didn't make a mistake, but at least we don't know that we did. And I would rather live in blissful ignorance. No, I think we did this one correctly. There's a lot of setup and there are a lot of places where you can go wrong with a careless mistake. A lot of bookkeeping, so it's always a relief after a problem this long to get a positive answer.